Hello everyone, welcome to Payment Tech Media. This is another example of IPv4 Class C subnetting. So let's go and jump into my computer and have a look. In this example, they gave us network address, default subnet mask, /24, the CIDR notation of a default subnet mask Class C. And then they are asking, we need 4 subnets. So we know by default, Class C network, the subnet mask is 255.255.255.0, and this is just one network, the 192.168.1.0 network. So we want to break this big network into multiple smaller subnetworks, and here they are asking we need 4 subnets. So how can we do that? Well, the first step, we need to write down the default subnet mask. So what is the default subnet mask for Class C? 255.255.255.0. This is the decimal format, so if we convert this to the binary, the first octet 255, that's 8 ones. So let's write down, because again, all these ones, when we add all these decimal values, it gives us 255. That's basically converting binary to decimal. I have complete crash course regarding all those number systems, how we can convert. If you haven't watched those videos, please make sure go back and watch those videos first. So here we are converting this binary to decimal. This decimal value of 255, it's equivalent to having 8 bits all turned on. Okay, this octet, the second octet, 255, same thing. We have 8 bits already turned on. And a third octet here, 255, same thing. And this is the original cut line. These are turned off. So here we can see on the last octet 0. So all the 8 bits turned off. And here we can see all these ones, that's network bits, zeros, host bits. And if we count all the number of ones, it should be 24. This is the default CIDR notation for Class C network. How do we know this is Class C? Because looking at the IP address, the first octet, 192. 192 falls into Class C network. Okay, now they are asking for 4 subnets. As we talked earlier, the number of subnets, it's basically 2 to the power of subnet bits. So we need how many? 4. So basically 2 to the power of, let's say, x equals 4. And this is just basic math, you guys remember? We learned about all this, so if in order to find the x, we just need to divide. So x equals 4 divided by 2, which is 2. So this is the number of subnet bits. 2 to the power of subnet bits equals whatever value. So they gave us, we need 4 subnets. So how many subnet bits do we have to get, right? In order to get the subnet bits, here 4 divided by 2 equals 2. So basically we need 2 subnet bits. Or in other words, as I mentioned earlier, to find the number of subnets going from left to right, starting at the bottom, starting with number 2, 2, 4. That's it. This is the number of subnet bits. 4. We can stop here. And the number of hosts we talked about going from right to left, starting with number 2, and then 4, 8, 16, 32, 64, and we have to do the -2 to find available IP addresses. 64 minus 2, 62. So in this example, we will have 4 subnets. Every subnet we will have 62 available IP addresses per subnet. So let's go over these subnets. Well, if we start from the 0 network, 192.168.1.0, and now let's write down the next subnet. The next subnet would be 192.168.1.64, where the 64 is coming from. Well, we have to take a look and see the last bit that is turned on. We borrowed how many bits? 2 bits, right? So let's erase this 2 and let's turn on these 2. So the last bit we borrowed, the decimal value is 64. This is our network increment or block ID. So 1.0, 1.64 on the last octet, because the cut line is on the last octet. In the next exercises, we will do the subnetting on Class B or Class A you will see then we will work on the third octet or on the second octet where the cut line is, then we just need to increment on that block. This one is a class C subnetting, and here we can see we are working on the last octet. So the cut line is on the last octet and incrementing by 64 on the last octet. So the next subnet would be 192.168.1.128. And the next subnet would be 192.168.1.192. And the next one would be 256, which 256 not valid. Therefore, these are our 4 subnets. And each subnet up to 62 available IP addresses. For example, if we take a look at the first subnet here, let's write the broadcast. Always the broadcast is one less than the next subnet. Next subnet is 1.64, therefore should be 1.63. So 192.168.1.63. And the range, first available IP address for this subnet is 192.168.1.1, and it goes to 192.168.1.62. So 1.1, 1.2, 1.3, and so on to 1.62. These are the 62 available IP addresses we can see in every subnet. Same thing, here we will have 62 available IP addresses in this range. So this is our network address here, our network address, and here is our broadcast address. And here in between, these are all the available IP addresses that we can use and assign to the computers, interfaces, basically to the network devices. So to quick recap, what was the question? They gave us the network address, default subnet mask, and they said we need 4 subnets. So what we had to do first making sure what class this is. This is class C. What is the default subnet mask for class C? 255.255.255.0. Why this is class C? Because looking at the first octet, 192 falls into the class C range. And drawing the default subnet mask cut line here, this is the default subnet mask because 24 bits it's for the network and 8 bits for the host. And then we had to borrow from the host bits. So we borrowed 2 bits. Why? Because when we borrow 2 bits, it will give us 4 subnets. We had this formula, 2 to the power of subnet bits. That's the number of subnets. In this case, 2 bits, right? 2 to the power of 2 equals 4. And the number of hosts at the bottom, going from right to left, starting with number 2. 2, 4, 8, 16, 32, 64. 64 minus 2. Why minus 2? Because 2 addresses we cannot use, we cannot assign to the computers on the network. One address is the network address and one address is the broadcast address. So this column is the network address column, and this column here, these addresses are broadcast addresses. That's why we need to do the minus 2. For the subnet, we don't do the minus 2 because we are counting the 0 network as well. So for the subnet, we don't do the minus 2. For the host, we do the minus 2. Or if we go by this formula, the number of hosts, 2 to the power of host bits minus 2. So how many host bits? 1, 2, 3, 4, 5, 6. Zeros are host bits. So 2 to the power of 6 minus 2, which is 64 minus 2, 62. So after finding out how many bits we need to borrow from the host, in this case 2 bits to get 4 subnets, right? Then we draw a cut line. So this is our new cut line. Originally, this was our default subnet mask, right, for class C network, but we moved this cut line 2 bits over. Now this is our new subnet. So what would be our new subnet mask? It is not 255.255.255.0 anymore. if we convert this binary to decimal, 128 plus 64, that's 192. So it would be, let me erase this one on the last octet. So it would be 255.255.255.192. That's our new subnet mask. And of course, it's not 24 anymore. That would be 26. Where 26 is coming from, if we count all these ones up to here, is 26 ones. So 8 plus 8 plus 8, 24, 25, 26. And the zeros, they are host bits, which here we have 6 bits for the host and we have 26 bits for the network. 26 bits for the network, which this will give us a total of 32 bits. That's IP version 4. How many bits we have in IP version 4? 32 bits. So this 26 bits would be our new network bits. Therefore, the new CIDR notation would be /26. And of course, our new subnet mask will be 255.255.255.192. 192 if we convert this binary to decimal. So here we have 2 bits on and we have 6 bits off. When we convert this binary to decimal, it is 192. Basically, we just need to add the decimal values that are already being turned on. In this case, 128 and 64 turned on. So 128 plus 64 is 192. And the last bit that is turned on, the decimal value for the last bit, that's our network increment. So starting from 0 network, 1.0, we are incrementing by 64, 1.64, 1.128, 1.192. We can't continue because we get to 256, we don't have 256. Every octet, the range goes from 0 to 255. 256, not valid. So these are the 4 subnets. And of course, every subnet, 62 available IP addresses. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.